in this series on Introduction to Science Education. Today we have with us Abhijeet Bardapurkar, who is a faculty member at the Azim Premji University in Bangalore. Abhijeet is a microbiologist to begin with. I mean, he did his master's in microbiology. And after a few years after he finished his master's and after teaching genetics, immunology, and other biology-related subjects, he switched gears and he moved into the field of science education. He went on to do his PhD in the Homi Bhabha Centre for Science Education, and his doctorate is in the field of philosophy of science and science education. He earned his PhD in 2009 under the guidance of Professor G. Nagarjuna. After this, he turned his attention towards teaching science education related subjects, which he taught at different places, including at HBCSC. He taught at NICER, he taught at the Ambedkar University in Delhi, and he also taught in the Tata Institute of Social Sciences in Bombay. He has taught a variety of courses, so philosophy of education, history and philosophy of science, cognitive psychology, and so on. So he's, deeply into this field of formal science, formal parts of or formal aspects of science education. And he is currently at the Azim Premji University teaching primarily in the MA education program of APU. His interests are in philosophy of science, and in looking at how particularly the areas of ethics relate to the field of education. So that's his current major research interest. Now, when we are discussing this topic for this series, Abhijeet was a little concerned that his abstract might sound a little intimidating because it has a lot of formal science education elements in it. When I reflected on this, I thought, well, this is actually a good thing to have, because there's a tendency among a lot of people to think of science education as an amateurish discipline, as a discipline that emerges somehow out of common sense. I mean, a lot of people seem to think that if I understand a subject well, and if I have a few ideas, I should be able to teach well as well. So thankfully or sadly, whichever way you look at it, this is not how it happens. There's a considerable element of research that goes into what good teaching is. There's a considerable element of research into what good education is and what methods work, what methods don't work. And it's actually a very, very strongly multidisciplinary area, which includes psychology, cognitive sciences, sociology, economic aspects, and so on, which are all important for good education, for research in science education. Abhijeet is widely versed in many of these topics, and I think he is the right speaker for the series that we have planned for our new department. And I hope that Abhijeet goes back with a good impression of how his talk has been and what kind of responses he gets. And we really look forward to you unraveling a few formal aspects of science education and the challenges that science education as a discipline faces. And of course, some of the details of your own research interests that you might want to touch upon. So the stage is over to you, Abhijeet. We can sort of aim to have a 40-minute talk followed by discussions. And if you wish, we could also take questions from the audience in between, depending really on what you prefer. I and Aparna will keep track of questions in the chat box. Sure. And we'll relay them to you as and when you feel ready to answer them, either in the middle or towards the end of the talk.
Yeah. Right. So, if there are clarificatory questions, or if any of the members of the audience are losing thread and getting lost and want to ask something, I will take the questions in between.
Okay.
if there are, questions which would need longer discussions or debates or whatever comments, then we will keep that at the end.
All right.
Questions are welcome in between if any of you are losing the thread.
Sure.
Yeah.
Okay.
So,
and let me just remind the audience that if you look at the chat box, there's a link which will allow you to sign up for further updates from the department. Okay. So please fill out your names in the form, in the link provided in the chat box. Thank you.
Right. So, well, if there are students if there are students who are logged in.
Yes, there are. I can see a few. Yes.
Yeah, I understand that 6 o'clock is not a good time to have a talk, and particularly a talk which tries to cover vast areas without going into details of any of which but I mean, what I would do is that I will lay out the canvas, as I said, not focusing on all the aspects of it, but some aspects of it. But if you have questions about any other aspects, etc., I'll be happy to talk about it at the end. And so suppose you think that I should have emphasized something, or I should have talked about some aspects more than what I did, then I'll be glad to have questions at the end on those things. Right? So let me start sharing the screen. Yes, is it full screen visible?
Yes.
Hello?
Yes, Abhijeet. Yes,
yes,
it is.
Abhijeet.
Yes, okay. So basically, let me show you the canvas as such, what I have in mind. So basically, can you see my arrow?
Yes.
Okay.
Yes.
So basically, we are human beings, and we inhabit two worlds at the same time. One is, natural world, nature, and another is human world. Okay. So so basically we are inhabiting these two worlds, and we of course we are born as children, and then we grow up to become adults, and we develop in the process, and we learn both about the natural world and about the human world. Okay. And how do we connect to the natural world or the world of human beings? Is through, basically there are two connections that we have with this world. One is through our sense experiences. Okay. So eyes, touch, smell, taste, etc. So through our sense experiences. And the other way to get in touch with this world is through our thinking, right? So through thinking and experiencing, we are in touch with the world around us, which has, two main aspects. One is natural world and another is human world. So of course, when we think about natural world, okay, the world which scientists study, a part of natural world is what we experience. So it is experiential, which we can observe, but part of it is there, but we can't access it through our senses. So, and that world exists, or we suppose that world exists, and let us call it real world, right? Now, this real world is revealed to us in the experiments that we do, or when we think mathematically or conceptually about the natural world, right? So this natural world, we discover in this natural world something like causal laws, basically those laws that govern the relationship among natural entities. And this makes science possible, right? When it comes to human world, we are not just worried about the knowledge of the world, but we also think about values, right? And of course, there are, we can talk about this later, but there are values, and basically the relationships among human beings are governed not by laws of nature, but the relationship among human beings are governed by what we call as moral laws, right? So just as causal laws make science possible, moral laws make human freedom possible. So basically, the point is that, as human beings, we learn and develop, and we learn and develop our understanding of the natural world and of the human world. Right? And while we are doing it, the positions or stance we take could be subjective or relativistic or objective. There is an interaction between individuals and the society of which those individuals are part of. And we have various beliefs about the natural and human world. And we have various values or principles with which we act both in the natural world and in the human world. Okay. Now, this is the canvas we have. Um, this is given to us as educationists, and I will talk about some aspects of it during this talk. It is impossible to talk about the many aspects, and there are various things I could have filled in here, but I have just kept it simple with some things. Okay, so let us begin the talk. Okay, so what is science education? When we think of science education, what is the object of study? Object of understanding and action, or object of intention and intervention of a science educationist? What is, if someone is interested in science education, what is that person interested in? What is the object of her understanding or her intervention? Well, it is science learning, right? So so just as science aims to comprehend and control the natural world, science education aims to understand and direct science learning. Science education aims to achieve the learning of science, right? So this is the object of science education. So when we think about science learning, basically we have to think about these three questions primarily. Okay. What is science? What is learning? And what is it to learn science, right? So scientists learn about the natural world, and science students learn what scientists learn about the natural world, isn't it? So this is what science students have to learn. But what about science teachers? Now, science teachers learn what scientists learn about the natural world, what students learn about the natural and human world in their everyday life, not in their science classrooms. Okay. What students learn about what scientists learn about the natural world, and what textbooks, media, parents, authorities say about what scientists learn about the natural world, right? So if some teacher is interested in teaching science, she has to take care of all these elements or aspects, right? When it comes to science educationists interested, of course, they are interested in science learning, science educationists have to think about or learn what scientists learn about the natural world, what students learn about the natural and human world in their everyday life, what students learn, what scientists learn about the natural world, what teachers learn about the natural and human world in their everyday life, what teachers learn, what scientists and science students learn about the natural world, what textbooks, media, parents, authorities say, what scientists learn about the natural world, what science historians, philosophers, psychologists, sociologists, and economists say, what scientists and students learn about the natural world, and most importantly, what good all these learnings achieve, right? So science education is, if someone is interested in science education, she has to have eye on all these elements or aspects, right? So um, so to learn science is to learn scientific descriptions of various aspects of the natural world. This is one part of it. Scientific explanations of various aspects of our experiences of the natural world. Okay. Scientific justification of these descriptions and explanations. Okay, that is, we, of course, in science, we describe the natural world. And I'll talk about each of these aspects shortly. But to begin with, to put the whole thing in one slide, to learn science is to learn scientific description of various aspects of the natural world. Then we explain our experiences of the natural world, and we justify these descriptions and explanations by evaluating and seeking evidence for these scientific descriptions and explanations. So to learn science is to learn knowledge in science and how this knowledge is developed by scientists, and knowledge about science. So there are two aspects, right? Science learning has two aspects. Of course, you learn knowledge in science and how this knowledge is developed, and you have to have knowledge about science, right? That is philosophical and historical development of scientific knowledge and practice, and its relationship with individuals and the sociology and the society, right? So so overall, we assume that there is the natural world that exists apart from us, right? And which has some basic constituents. Forget about these, um, these words, but we assume that something exists apart from us. Let us call it reality, and we are capable of experiencing at least parts of what exists apart from us, and we are capable of representing these experiences, we are capable of describing these experiences, and we are capable of explaining these experiences and descriptions, right? Using theories, ideas, concepts, right? So and we justify our explanations and descriptions, right? How do we justify? We look for, observational or experimental evidences, or conceptual evidences and coherence with our explanations, and we think is the postulated reality, because all the reality we can't experience, right? So we postulate some of the reality, but we see whether this postulated reality is consistent with our experiences, either general commonsensical experiences or experiences that are specially arranged during scientific experiments, right? So this is the whole picture, if it helps you, right? So there is reality, there are experiences of reality, then there is description, then there is explanation, and then there is justification, right? So so now let us focus a little bit more on scientific descriptions. Okay. If something is not clear, you may please ask the questions. Okay. So there are scientific let us focus a little bit more on scientific description. Now, scientific descriptions are not always, or for the most part, same as commonsensical descriptions. Okay. They are often narrower, more specific, focused, and go beyond what is immediately available to our senses. Scientific descriptions, as you are all well aware, they are abstract, idealized, and often expressed in the formal technical language of science, mathematics, statistics, etc. Right? And remember, when we think of scientific descriptions, we have to distinguish between commonsensical descriptions of appearances, the world as it appears to our senses, and the scientific descriptions of reality, right? So there are entities that we cannot experience with our senses, but we postulate, right? So, for example, genes or fields or electrons. So when we describe these things, we are actually not describing what appears to our senses, but we are describing what lies behind our senses, right? So there are commonsensical descriptions of appearances and the scientific descriptions of reality. Now, this is an important distinction because, if you don't pay attention to this distinction, there will be problems that some science students may face while learning science. And often these descriptions, so the descriptions, when we talk about scientific descriptions of reality as opposed to scientific descriptions of appearances, often these descriptions are themselves explanatory, right? Scientific descriptions of reality. These descriptions are themselves explanatory when these descriptions of postulated, hypothesized causes, when these are the descriptions of postulated, hypothesized causes, right? Descriptions of the causal structure of the world, right? So often when we think of scientific description, often we describe the causes, and when we describe the causes, we are explaining something, right? So it may help us give causal explanation of some of our experiences. So there are descriptions that demand explanations, and there are explanatory descriptions, right? So now let us turn briefly to scientific explanation. Of course, I have to do it quite quickly. So scientific explanations are either in terms of laws of nature or in terms of causal entities that are real but unobservable. So if you assume that scientific entities like genes and electrons represent reality, there is a reality which you can't sense, see, or touch, but there is a reality that exists. And if you assume that there is such reality, that scientific entities like genes and electrons represent reality, then you are a realist. If you assume that scientific entities are just prediction tools, then you are a pragmatist. If you are a pragmatist, you value usefulness. No, you think that what is useful is what is good. If you are a realist, you value truth. You think that what is true is what is good.
Abhijeet,
Yes.
there is a question in the chat box
Yeah.
related to your previous point about making a clear distinction between what you call scientific and what you call commonsensical. If you could give an example of this, the question in the chat box could be answered.
Okay, so just sorry, this chat, I have opened the chat now. Okay.
So, shall I read
So
the
can
question
you can
out?
read it out, right? Yeah.
So the question is, can the distinction be made clearer with an example of scientific and commonsensical?
Okay, so suppose I'll take this distinction which through which we have all gone through. So suppose I have fever and chills and I'm not feeling well and maybe losing the sense of smell, etc., right? So I go and describe this to a doctor, right? What I am having, right? My symptoms, right? And then from my symptoms, the doctor may infer, right? The doctor may not observe or see, but now this inference is an important word. The doctor may infer that I am suffering from, some kind of disease caused by some germ, right? Okay, maybe some virus, right? So maybe some virus is circulating in my body and the doctor may infer its existence. Right? Now, of course, you can say that, look, you can describe my condition as you are being infected by so-and-so virus, right? Now, this is a description of my state, right? But this is not a commonsensical description, right? That you are infected with so-and-so virus and the virus is circulating in your blood and causing all these symptoms. It's causing all these symptoms, right? So this description is a scientific description, isn't it? Or let us take the example of Mendel. Mendel thought that there are particulate hereditary factors which are transferred from one generation to another generation. And when the characters are passed from one generation to another generation, those characters blend with each other. So if the mother is dark, if the mother is tall and the father is short, or if one plant is tall and another plant is short, the next progenies will have a height somewhere in between. It is neither tall nor short, right? So, but Mendel for the first time proposed a theory of inheritance where he thought about the particles which are the hereditary factors which are hereditary factors which are particulate, right? So now this theory of inheritance proposed by Mendel is a description of what happens during reproduction, right? Okay, but this is a scientific description or causal description in which you are describing entities which are not available to your common sense. Okay, so this is what I mean by the scientific descriptions of reality, and these descriptions are explanatory because these descriptions are describing the causes, okay, that explain the effect that you can experience. So what are you experiencing? You are experiencing effects, right? And the descriptions are explanatory because they are describing the causes which are responsible for the effects that you observe. So there is a certain pattern of inheritance, right, that you see across generations. Fine. So this is what. So is this clear? Or whoever has asked the question?
Yeah,
Nishad has said,
it has.
Okay, fine. So So I think yes. So this distinction between, yes, realist and pragmatist, this distinction. Look, I may not be able to explain the significance of all these things in science education, but I'll try to, okay, do it later as we go by. So then now there is, so when we talked about, you remember this, this chart, sorry, this one. So we have talked about the description, explanation. Now let us come to justification, right? What makes an explanation a scientific explanation? Explanations that are comprehensive, which have explanatory depth and breadth, right? So for example, a theory of natural selection explains so many. It explains adaptation, it explains diversity, at the same time. And of course, all of you know Newton's theory explains so many diverse phenomena. So it has explanatory depth and breadth, and the explanations are productive. They are capable of making novel predictions, and the explanations are coherent with each other, and they are elegant or simple, right? So explanations that are well supported by appropriate evidence across space and time. Evidence should be relevant to the explanation at hand, and evidence should be sufficient in the eyes of the scientific community, right? So this is what makes, then we say that this explanation is justified as scientific explanation, right? So this is scientific justification. So this scientific justification is based upon certain scientific values or principles. Okay, so scientific justification refers to the principles, values, standards based on which scientific descriptions and explanations are developed, communicated, and evaluated by the members of scientific communities. Right? So, so in sum, then, science learning, to learn science is to learn scientific knowledge or theories, which is description, explanation, and learn the scientific practices necessary for the development and justification of the scientific knowledge. And this is very important, learn the principles or values with which this scientific knowledge, these scientific theories and practices are evaluated by the scientists. For example, how evidence relates to and justifies the explanations as true and therefore scientific explanations. That is, explanations that have succeeded in capturing the relevant aspects of real natural world. Okay. So, of course, pragmatists or empiricists will not, they do not believe that we know what is real natural world, but that is another point. I mean, I don't want to go into those details here, but to learn science is to learn scientific knowledge and theories, learn the scientific practices necessary for the development and justification of these scientific knowledge, and learn the principles or values with which this scientific knowledge and practices are evaluated by the scientists, right? So this is the summary of what we have discussed until now. So learning science is to learn both the theories and values in science. Learn the necessity of values like tenacity, perseverance, rigor, of being systematic, trustworthy, courageous, open-minded, transparent, fair, objective, just, temperate, etc. Value these you value these values. So for example, if you have imbibed right scientific values, then you will value and communicate equal evidence equally, and unequal explanations of varying explanatory depth and breadth unequally, right? So for example, while being committed to the central dogma of molecular biology, you duly acknowledge the evidence for epigenetic inheritance, or you debate whether 30 mutations in the spike protein of the coronavirus variant is an evidence for its heightened virulence or pathogenicity, right? So you are capable of evaluating all these claims. Note that these are the principles which are, that means standards of behavior and judgment, to assess the development of ideas and practices and help sustain the success of science, both epistemic and pragmatic, right? Theoretical and practical, both of knowledge and of technology. And these contribute to the development of the larger educational goal of being good and building a just human society, right? So, so you have to learn, of course, knowledge and its development, the practices which sustain the development of this knowledge, and the principles on which these practices and this knowledge is evaluated and justified as scientific. Okay, I hope this is clear. Now, so learning science has two sides to it. Okay, one is learning explanations, and another is learning evidences for those explanations, right? Learning the content of science, web of theories, ideas and concepts of science, and learning the aims and practices of science. Activities that scientists engage, like verification, corroboration, prediction or control, argumentation, and its communication, right? And in both the cases, you learn explanations and you learn the standards, principles, or values to evaluate these explanations. You learn evidences and you learn the standards, principles, or values that should govern the practice of science, right? And you learn to relate explanations with evidence. Focusing on the one without adequate reference to the other is a recipe for imbalanced science education. So I won't go into details of this. Maybe we can talk about it during the question answer session. So this was about learning science. So when we think of teaching science, okay, of course, to learn something is to learn its development, and in turn to learn to contribute to that development. Scientific ideas and practices have developed painstakingly across dozens of civilizations. Therefore, to learn to teach science presupposes an understanding of the nature, which is philosophy, and development history of scientific ideas and practices. Now, so you should know what ideas and theories developed, how did they develop, and why, that is what for, with what aims in view. So when those theories were developed, there were certain aims that must have been in the minds of those who developed those scientific theories, right? So teaching science requires, understanding which is philosophical and historical. Of course, it is not only science that develops, but children who are expected to learn science develop too. And so does the society to which they belong. And in science learning, philosophical and historical development of science interacts with the psychological, intellectual, and social development of children. So, for example, good learners appreciate the foundations of and the warrants for knowledge claims. They know when to ask questions, how to challenge claims, where to go to learn more, and they are aware of their own ideas and how these ideas change over time, right? So, so this was about importance of philosophy and history of science, and about psychology and sociology. And now there are two theoretical positions that are of significance here, and one should have some reference to that. So the question at stake here is, how do individuals relate to communities and societies, and how communities and societies relate to individuals? So there are two positions. Position one, this position argues that individuals make up the communities and societies. So thought and character of particular individuals defines the culture of the society. So society is a collection of individual lives, right? This is first position. The second position says that no, individuals do not make up societies, but it is the society that makes up individuals, right? So society, social norms, expectations, practices, and beliefs determine the character and thought of individuals who are part of that society. Okay, so an individual is a reflection of her society. Now, there are, of course, philosophers who have taken both, best from both of these positions, but not every thinker and practitioners is as nuanced, and one can easily fall prey to the extremities of one of these two positions in education, including science education. So, for example, if one is dogmatic about the view that the community does or should determine beliefs, values, practices of all the individual members of that community, then one falls prey to educationally undesirable vagaries of relativism. If social determinism is correct, then there are no individual objective values, as values are always relative to the norms of this or that society, right? So if you think that society determines the character of the individual, then what the individual believes or values will always be with reference to that society, right? So there is a kind of relativism then, right? Which is not good for education as such, right? So
Abhijeet, I have a question here.
Yes.
On these two positions that you mentioned.
Yes.
So I mean, to me, it seems that these two positions are also politically loaded.
Yes.
In the sense that your position one is probably more relatable to a democratic setup, while the second one is more closely related to a communist or a socialist.
That's right.
Setup.
That's right. So second position is called, I'm not using the technical words, but the second position is called communitarian, and the first position is liberal. Yes, that's right.
Okay.
Yes, right.
So, and these people who are sort of the proponents of these two positions,
right?
I mean, I think historically they're also related to countries or places where these two political thoughts prospered or took root. Is that right?
That's right. Yes, that's right. Absolutely right. Yeah. But the problem is that, as an educator, if you are, if you kind of go towards, but let us talk about it later. Yeah, I think. Yeah.
Okay.
So now, then, having discussed science and some of the aspects that are necessary for education from the point of view of science, let us think about how human beings, scientists included, learn, right? Now, again, when we think of learning, again, there are three positions, okay? One is empiricism, another is rationalism, and the third is constructivism, right? So on one hand, we talked about these two positions, which relate individual to community. Now we will talk about three positions which are central to understanding learning as such, learning in general, right? Including the learning of science. So empiricism says that we learn from sense experience. To learn is to see, hear, test, touch, etc. The source of human knowledge and human practice is in the sense experience, right? So this is roughly empiricism. Rationalism says that no, we don't learn from experience, but we learn from reason, right? So to learn is to learn to think properly, logically, coherently, consistently. Experience is an illusion. Knowledge is given to us in our reason, not in our senses, and disciplined reason to understand or grasp the reality that lies behind the apparent sensory experiences is the goal of knowledge, right? So this is rationalism roughly. Now, constructivism argues that knowledge is neither given in human experience nor in human reason. Knowledge is a free human construct. Okay, we have categories of mind to structure sense experience, to develop various claims to human knowledge, and in order to be rational or scientific, ideas constructed by human beings have to meet the human standards that in turn refer to reason and experience. So constructivists don't deny that reason and experience has a role to play in our assessments of our constructs, right? But the human knowledge as such is constructed by human beings, right? It doesn't come from reason or experience, although we refer to reason and experience to evaluate those constructs, right, as scientific or non-scientific. Often rational human constructs are very helpful in predicting or controlling the normal course of nature. In fact, they are good guides to the real natural world that is not available to frailties of human experience. Therefore, rational constructs could reliably be considered as objective descriptions of the real natural world. Okay, not final or ultimate, and yet objective and real, and therefore scientific. So as far as learning is concerned, we learn neither from experience nor from reason, but at the same time, both are necessary if we are to learn anything of value about the natural world, right? So this is constructivism. Of course, to illustrate this, I will quote Einstein, right? So Einstein says that during the year in Arau, the following question occurred to me. If one chases a light wave at the speed of light, one would arrive at a time independent wave field. But nothing like that really seems to exist. That was the first childlike experiment in thinking about special relativity theory. Now he says innovation itself is not the result of logical thought, even though the end product is tied to a logical structure. Okay. Now, physics is not my field, not certainly Einstein, but I was reading this autobiography just before a couple of weeks back, while preparing for this lecture. So I'm quoting, right? But this is an important point that he makes, that innovation itself is not the result of logical thought, even though the end product is tied to a logical structure. He also says that I see on the one side the totality of sense experiences, and on the other, the totality of the concepts and propositions. The concepts and propositions get meaning or content only through their connection with sense experience. But remember that this connection is purely intuitive, and it is not a logical connection. So the connection between our sense experiences and the constructs, the scientific constructs that we have or make, this connection is not logical in nature, right? In other words, experience does not determine our constructs, but it gives meaning to it, right? Nor the logical thought determines those constructs, right? So the degree of certainty with which this connection can be undertaken, and nothing else differentiates empty fantasy from scientific truth. Okay, I will skip this because there is no time. So if you are a science educationist, and if you put all your eggs in the basket of experience, you are an empiricist. If you put all your eggs in the basket of reason, you are a rationalist. If you put your eggs in both the baskets, that is of experience and reasons. Distribution may vary from the domain of your studies. You are a constructivist. Okay. Now, science is not possible without experience or reason, but ideas and theories in science do not come from experience or reason. Now, this puts severe the hope of feeding in the sense experiences to get children to learn scientific ideas and theories is misplaced, if not wrong. Okay. Giving experience is not giving ideas, theories, and hypotheses that explain those experiences. Experiencing something is not same as learning the science of it. So development of knowledge always begins with something that is already there, some categories or structures or existing ideas or theories. This is what constructivism argues for. When a science student enters the science classroom, she already has something in her mind and habits. The teacher cannot afford to ignore this. Science teacher has to mediate between the students' ideas and scientific ideas to take the students from the one to the other. Learning science is learning to differentiate between the constructs of science and the constructs of everyday common folklore, and why only some constructs are admitted in the fold of science, while others are rejected as non-scientific or unscientific. So constructivism does not advocate a curricular shift concrete activities to abstract ideas. It is not an advocacy for age-appropriate curricular content. Constructivism is not a theory of activity-based experiential teaching learning. What children are capable of at a particular age, I'm quoting here from Dashiell's work, what children are capable of a particular age is the result of a complex interplay among maturation, experience, and instruction. What is developmentally appropriate is not a simple function of age or grade, but rather is largely contingent on children's prior opportunities to learn ideas and concepts. Development is not a kind of inevitable unfolding in which one simply waits until a child is cognitively ready for abstract or theory-based forms of content, right? So it will be good to science, it will do good to science learning, in my view, or in the views of those who understand the relevance of constructivism for science education, to introduce theories such as cell theory, germ theory, or atomic theory in the earlier grades or classes. So students' explanatory ideas, their hypotheses or theories, and the constituents of the natural world of their imagination, that is their metaphysics or ontology, may not be scientific or closer to the scientific theories. Okay. So children already have certain ideas, and children already have some imagination of what are the constituents of the natural world, right? Now, these, what children's imagination of the natural world and the ideas they have, it may not be scientific or closer to the scientific theories. It may be complex and complicated, but not always ready to be developed or changed in the directions that the science teacher would like them to be. So a science teacher is a constructivist, but at the same time, she ought to be objective and committed to the principles or values that demarcate science from non-science. Now, this is an important point, because constructivism always slides down either in empiricism, or constructivism always slides down into relativism, and both are educationally harmful. So therefore, you have to be constructivist, but at the same time, you ought to be committed to take these constructs of children to the scientific. So for example, Einstein says that the quest for truth is more delightful than its assured possession. So I think I'll skip this now. So science is good because it is successful. It is successful because its predictions come true. Its predictions come true because its explanations are tentatively true. Its explanations are true because they refer to what is real, right? Good human life is life lived in reverence to the real, life of truth, not illusions. Good life is not a life of ignorance. Science is not sufficient for good life. It is not the only path of truth, but a necessary one, right? So to learn science is to construct and value ideas for their true, as far as we know, and therefore good, as far as we could. Okay. So I'll stop here and I'll leave you with this quote from Toni Morrison. You can read it on your own. I have few more slides on the suggestions of what what kind of work students at ISER may do in the area of science education, but we can do that after we take some questions, if there are any. Yeah. Thank you.
Abhijeet, thanks. There's a question pending from a little while,
Okay.
which is about, which asks, what do you have any comments on Indian schools of epistemology and ontology, and how do you place them on your canvas?
Yeah. So I think when it comes to epistemology, first of all, I should admit that I do not have any expertise to comment on this aspect, but definitely when it comes to epistemology, whatever little I know, I don't see it in contradiction with the Western epistemology, right? So of course, sometimes so for example, Indian epistemology demands that you not only give evidence, but you also exemplify your claim, right? So so I don't see that Indian epistemology will be in contradiction with, will contradict Western epistemology, right? Or Western modern epistemology. So I don't, my intuition is that there is very little chance of contradiction. When it comes to ontology, it's a very different matter. Okay. So because even in Indian thought, I think different schools have different ontologies, right? So ontology is a completely different ballgame. So, but epistemologically, I don't see any reason for contradictions. Yeah. But of course, I would like to mention one thing. Often I see the works, I don't need to mention them here. I see the works which confuses Indian philosophy and Western philosophy so much, and it neither does service to Indian philosophy nor to Western philosophy. So I am very wary of those who mix these things unknowingly, that they are mixing it. So one should keep these separate. Yeah. So my brief answer is that epistemology, I don't see any contradictions. And of course, I mean, it goes without saying that one should always think about ontology and epistemology together in any philosophical system. Okay. So ontology is very important. Even in science education, the ontology of, ontology means, for those who may not know this word, what basically exists in this world, right? So, the ontology of the students is, to know the ontology of the students, to know what exists in this world in the eyes of students that to whom you are teaching is very important. Yeah.
Abhijeet, there's one other question related to the constructivist approach.
Sorry, but I think Sujata raised hand before that, so maybe we can give her a chance. Yeah. Sujata, please go ahead.
Yeah. Hello, everybody. Hi, Abhijeet.
Hi.
Yeah. So I just want it just to take Professor Babbitt's idea a bit forward to understand things better. So it is regarding the individual and social constructivism, that is Piagetian versus Vygotsky educational theory. So if we are accepting the fact that their educational theories have been influenced by the place that from the place that they have come from, does it not mean that the Vygotskian theory is more evolved because that society has influenced their ideas and viewpoints about the educational theories?
No, they are different takes, right? So they are different takes. So for example, look, I mean, for example, for Vygotsky, thinking is internalized language, right? And for Vygotsky, development follows learning. So in fact, learning is necessary for development. And Vygotsky clearly says that scientific ideas or evolved scientific ideas have to be taught, and the students have to learn it in order to develop it, right? So neither the Piagetian constructivism, and for Piaget, thinking is internalized action, right? So basically for Piaget, initially you act at the sensory motor level, okay, and then you act at the mental level, right? And then thinking actually is internalized action, so it's some kind of mental action. So now both of them are constructivist in the sense that you don't begin with blank slate, you begin somewhere. So for Piaget, you begin with sensory motor structures, okay, and you begin with sensory motor action, and then you develop into mental action. So you begin somewhere, and of course for Vygotsky, you begin where the society is, right? I mean the social ideas or social norms. So the beginning points are different. For Vygotsky, the beginning point is located somewhere in society, whereas for Piaget, the beginning point is located somewhere in the structures, to begin with sensory motor structures and then mental structures, right? So these are these are two different views on learning and development. For Piaget, learning follows development. For Vygotsky, development follows learning, right? So these are two very different, these are different understandings of the same thing. Now, I'm not sure why one should say that one is more evolved than another one. It's like saying that, one variant of, anyway, I won't go, probably that example may not work here. But yeah, I don't see why one should be more evolved in, am I making sense, Shweta?
No, what I mean is, like, in case if we agree that the place that they are coming from influenced their educational theories,
Yes.
then in that case, the society has influenced, is what we can sort of, think, isn't it?
Yes, no. So for example, Piaget's theory is a response to behaviorism and empiricism, which will be called structuralism because structures are important, right? So I'm not sure. I'm not following your question. I'm not sure.
Okay, it's okay. It doesn't matter. Maybe I'll read at my end to get a better understanding. Yeah.
No, but I'm not sure. Yes, it's true that both Piaget when he was developing his theory. So Piaget developed his theory following Immanuel Kant, right? So Piaget basically what Kant did in philosophy, Piaget did in psychology, right? So yes, so they were responding to behaviorism in some certain sense, and Vygotsky was responding probably to, and Vygotsky must have been influenced by Marx's theory, the communitarian thesis. So that's true that they were working or responding to certain predominant theories of their time. That is true, but I don't know then why one should be more evolved or better than another thing. Yeah, I'm not sure. Yeah.
So Abhijeet, maybe you can go to the other question.
Yes.
This is a question from Nishad, who's asking, how does one, in a practical sense, a teacher can implement a constructivist approach in the classroom?
Okay.
A steep challenge here.
Yes, so in a practical sense, if you are a constructivist teacher, you always know that your students have certain ideas and certain views and certain imaginations and certain habits and values. Okay, you always know. Now the challenge for a constructivist teacher, and those may be implicit, right? Even though students may not know that they have those ideas, right? Or those thoughts or those values. Now, and suppose there are 30 students in your classroom, and particularly in Indian setting, when students come from diverse backgrounds, right? Those ideas or those values or those habits may not be shared. So the challenge of a constructivist teacher is to bring the ideas or the values relevant to the topic at hand, okay, on the table of the classroom, right? That is the first thing. And the second thing is that, in fact, I have slides about it later. And the second thing is that, so first thing is that you make students talk on the ideas or principles that are relevant to the topic at hand, right? Whatever may be the topic. So you may ask them to talk about, so for example, if you are thinking about matter, or if you're thinking about cells, or if you're thinking about life or plant, you make them talk about those things so that their ideas, and some of them may be explanatory ideas, right? And their imagination, worldview related to that domain comes on the, is on the table of the classroom. So all the class knows that, these students think about these natural phenomena in this way. Okay, she has this in mind. So now that is the first step. The second step then is the teacher should be capable of, once all these ideas are all these commonsensical or naive or everyday ideas about that natural phenomena in the classroom, right, available to everyone, then the teacher should be capable of comparing these ideas with the scientific ideas, and then lead the whole class towards understanding how particular set of scientific ideas explain the same thing, right? So the teacher should have some kind of expertise to compare the ideas and thinking of their children. First, make them explicit, right? And then compare it. And there is this concept of learning demand that John Leach and Philip Scott and Miller and Rosalind Driver came up with. Learning demand. So a teacher should know the learning demand of that classroom by contrasting or comparing the content and nature of scientific idea, scientific explanatory idea, and the students' ideas. Once you know the gap between the two, you know the learning demand of the classroom, and then you kind of teach in such a way that students understand that yes, they thought that these are the ideas that are relevant to that phenomena, but this is how the science thinks about those phenomena. This is how science describes and explains those phenomena. So this is what the constructivist classroom will look like. Now the question of how you do that, I personally feel should be left to that teacher, right? Whether she will do these activities, that activities, or whether she will simply use the chalk and talk method. So those are, I think, the question of how then the teacher does it and I think that the teacher should have freedom to do that. Right? So we have to answer what and why before we go to how. Often in education, we begin with how, but we have to begin with what and why, and then go to how, right? And that will preserve the creativity, dignity of teacher. And anyway, all the learning demand of all the classes is not going to be same, right? So the teacher has to have a capacity to, help students understand their own ideas. Okay? So that's how the constructivist classroom will look like, yeah, according to me, yeah.
Abhijeet, there's one more hand raised and probably another question too.
Yeah.
So Rohan, can you go ahead with your question?
Yes. Am I audible?
Yes, you are.
Yes. Thank you for the talk. And my question is somewhat related to Sujata ma'am's question. It's so you said that there are two theories, liberalism and communitarianism. So where society makes up the individual, and in the liberalism model, the individual makes up the society. So what my question is, isn't education, and to be specific, teaching, because education and teaching should be a social process and it's supposed to be a collective experience, shouldn't the teaching and education be more related to the Vygotskian perspective as compared to the Piaget perspective? So what my question basically is that Vygotskian perspective, then comes education, and then comes the liberalism model instead. So I may be wrong in this, but shouldn't that be the case? Because the way we are taught.
No, actually, both the perspectives are necessary. There is a very good paper by Rosalind Driver, Constructivism in the Classroom. And
Okay.
she usually explains why both the perspectives are equally necessary and helpful.
Right.
It may be, even if you agree for the sake of argument, okay, that all my ideas come from society, okay, suppose you agree.
Right.
Fine. Now, yes, all my present ideas come from my society, but all the ideas may not be scientific, right? Isn't it? Right. Now, how a particular idea explains a particular phenomena, either coming from society or coming from science, that I have to make sense at the individual level, isn't it? Right.
Right.
So even if you agree with Vygotsky, even if you agree that language is very important, and all thinking is interiorized language, and the categories of our thought do not come from we are not born with the categories of our thought or some sensory motor structures that later develop into mental structures, but all our concepts and categories come from society. That means come from cultural practices and language. Fine. Okay, fine. Let us agree that. But how these concepts or ideas relate to phenomena at hand, how these concepts and ideas explain those phenomena, and why only some of the concepts and ideas are accepted as scientific, whereas others are not accepted as scientific. What are the grounds of some of the ideas to be accepted as scientific, whereas others? So these these things, I have to make this, at the individual level, I have to make the sense of it, isn't it?
Right. Yes.
You agree? So therefore, the learning ultimately has to happen at the level of individuals.
So Abhijeet, I just wanted to chip in with one query or an idea, which is that okay, so let's say we accept the Vygotskian viewpoint.
Yeah.
So that's probably okay as of today for an individual, but as the individual grows and the individual puts out his or her own ideas, they are essentially a self-construction.
Right. Right.
And that would then feed into the society of tomorrow.
Yes.
So at the best, the Vygotskian point of view would be applicable in sort of as a cumulative effect of the past.
Yes.
But cannot lead you to the future.
Right. I think this is an important point. This is an important point for Vygotskian. The point that you made, that okay, if society determines all the individual ideas, then how do these ideas develop, right? Suppose there is an individual genius, right? Who wants to reject all the all the popular ideas or all the predominant ideas and come up with something new. How this happens then, right? So this has to be this has to be so that's why I said that social determinism, if social determinism may put conceptual constraints on the possibilities that there may be individuals who may come up with certain ideas which are revolutionary, right? So I mean, that's an important point. I don't know whether Rohan agrees with this or not.
Abhijeet, in adding to what you said and expressing my viewpoint on what Rohan said, how I view the two theories are something like this. Like, if we go by the information processing theory, where the information is processed within the individual person's brain and mind, then the factors which influence the external or the environmental factors which influence this kind of a processing of information happens through the Vygotskian model, where you have this community of learners coming into the play, and then you're working as a group, and then you have this zone of proximal development, etc. So does it make sense if I have to think of the two theories in this way?
No, I'm not sure. See, zone of proximal development, as I said, and as I understand it, maybe my understanding of Vygotsky is more limited. But when we think of learning, there are various ways in which we make sense of learning, right? No, I'm not sure. So zone of proximal development is a simple idea. It says that, look, I mean, instruction is necessary for development. Don't think that ideas like justice or relativity or natural selection, okay, could be developed by children during their normal course of, they have to be taught to them in some way. And in fact, teaching of such ideas is necessary for development. So you have to push the child to develop in these directions, to develop her understanding in these directions. How do you push it? Through instruction, right? So, there are ideas which are not commonsensical, and children are not going to develop on their own to acquire these ideas. How do you make them acquire these ideas? You instruct them, you teach them, you help them, you scaffold them to learn those ideas, to push their development, right? To give boost to their development. So this is, I mean, zone of proximal development is a very simple concept in this sense, right?
Yeah, that's the environmental influence of on the learning process, right? Whereas the Piagetian's individual constructivism is something related to what's happening within the brain.
No, it's both, because there is equilibration and what is it called? Assimilation and accommodation, right?
Yeah.
So, both, look, I mean, constructivism, whether it is Piagetian or Vygotskian, is always, is always an interaction of what the individual has and what the environment gives, right? So in both cases, environment has a role to play. The difference is where you begin, right?
Okay.
That's the difference.
Yeah, thank you, Abhijeet. Thank you.
Okay, so
but I mean, the more important points which I had in mind is that, what the danger is that one slips into some kind of relativism or empiricism while thinking about these issues, right? Either, predominantly the social constructivism or determinism, or these things. So I had those concerns which I wanted to highlight, during the talk. I don't know whether I'm successful in that. Yeah.
Well, it was an interesting talk. You
Yeah.
touched upon a lot of things which
Yeah.
many of which were new to us, and I thank you for your time.
Well, thank you. Yeah.
And I also thank the audience for participating with their questions and their own points of view.
Yes. Yeah.
Well, we would have liked to have had Abhijeet here in person, and he too very strongly preferred that. But well, given the constraints,
we
had to.
Usually, and right now I have relied on the slides, which I mean, generally it would have been
right. But I'm sure there'll be more opportunities
Sure.
For us to meet, and it could be quite soon.
Sure.
We are fairly returning back to normal in our campus here. So thank you very much, Abhijeet, and thanks to the audience for your participation. And let me again remind you, there's a link at the top of the chat box to fill out a form in case you are interested in being served from our email communications concerning these talks and other activities of the department. Okay, so Pooja, Aparna, do you have anything to add?
No, that's it. Thank you very much, Abhijeet. This was great fun.
Thank you.
Very, very engaging talk and lots of new things. And I will email you later about a couple of things that I wish to ask. Thank you.
Sure. So I had certain slides for what students can do, but I think we can leave it for some other time.
Yeah, I think we should leave it for some other time.
Yes.
Sure. But we'll keep in touch.
We are planning a workshop specifically for students in the coming months. So I think we can maybe invite you then and have you as part of that workshop.
Sure.
We're thinking of something like early next semester. Yeah, early next semester.
Yeah.
In person. Let's emphasize on that.
No, definitely in person.
Thank you.
Thank you.
Thanks, Abhijeet.
Thank you for your patience, and I hope it may be of some help. Yeah. Thanks.
Yeah, and we'll stay in touch for sure. Yes.
Sure. Okay.
Bye.
Thanks. Thank you, everyone who joined.
Thank you. I'm going to end the meeting.